Hey everyone, my name is Fraser Cain, publisher of Universe Today, and this is your weekly space hangout for Friday, November I have to look,
20th.
20th, 2015. Joining us this week, we may or may not have a special guest. We're still trying to wrangle that. But until then, we've got fan favorite, Kimberly Cartier. Hey, Kimberly.
Hello, Fraser.
And
world.
And we've got Morgan Remberg. Hey, Morgan.
Hey, Fraser.
So we're gonna sort of fill the time and talk about a pile of stories, and we might have a little more time to answer some of your questions, especially Kimberly's aliens. So, oh, she's never going to escape. Every time. Well, Kimberly, you were interviewed on some radio show or something?
Yeah. So earlier this week, I woke up really super early and made my way over to a local radio station to talk about exoplanets in general. And one of the pieces of news that he brought up, he was like, "Oh, can you talk to us about this whole alien megastructure thing that's been in the news recently?" And I said, "Oh, well, I can actually talk a lot about it because I was part of that discovery and that whole media frenzy that happened." So it's one of those things that it catches the attention of a lot of people and it sticks in the mind. So if you want to ask about it, all you viewers, I actually don't mind talking about it, I promise, despite the funny faces I make.
It was like poor Ian O'Neill. I don't know if people remember Ian O'Neill. He did an article for us at Universe Today about the 2012 controversy, like back in 2010, about how 2012 wasn't going to be a big deal. And then we saw like a lot of people really quite excited about that, and so he did a whole series about the different crackpot theories, and he became the 2012 guy, and he was like on television shows and all that, and he went over to Discovery and he kept that legacy going. And it really became a career for him. And now the 2012 has passed, he gets to be his regular job of being the editor of Discovery Space. But it was pretty funny there for a while. All right, well, let's. So I just want to remind everybody that this is a live show, and wherever you're watching this, you can interact with us. Just go ahead and use the Q&A app. So just click madly at the screen wherever you're watching it. It should pop open another screen that you can still watch the video, but then there's also a bunch of comments on the side, and you can post a question and I will see it, and I promise you we'll be able to answer tons of questions in today's show because we were planning for a guest and no guest yet, so let's do it. So let's pick one of the random topics that we have in front of us. Let's start with Kimberly. Let's talk about observing exoplanet atmospheres from the ground, which is like one of my most excitements.
Yeah, so in the past 20-odd years since we found the first exoplanet, we're getting really good at finding exoplanets and figuring out their general size or their mass or possibly both. And so when we're looking towards the future of figuring out exoplanets, we're really trying to figure out whether or not they're habitable. And I think I've mentioned on this show before is that regardless of where a planet is in its solar system, what really determines if the planet is habitable in terms of like surface temperature and the conditions on the surface like that, it's really the atmospheres of the planets that we need to know. And when we're looking forward, we think, the James Webb Space Telescope will obviously look at all of these exoplanet atmospheres and tell us if they're really habitable. But the exciting news is that there is a group of astronomers who have shown that we can actually do this from the ground now using telescopes that are only 1 meter to 2 meters in size. It's a very small telescope discovery.
Explain how.
So what they were doing, they were looking at a planet called GJ3470b. It is a Neptune-sized planet and Neptune-massed planet. It's a bit warm, it's around an M dwarf, and they were using a technique called transmission spectroscopy, where they're observing the planet transiting, and they're observing it at various different wavelengths. And when you look at a transit of a planet in different wavelengths, what you're really doing is you're seeing the apparent size of that planet as a function of wavelength, which tells you what kind of atmosphere that planet has. And this is a very special target. We can't do this with all planets, but this is a special target that we were able to observe from the ground because the planet is pretty large compared to its very small host star. And so the signal was very large.
And so you're able to get the composition of the atmosphere. Are you able to get a sense of the temperature of the atmosphere?
Yeah, so the temperature of the atmosphere is still really a function of how far away the planet is from the star. And then the temperature at the top of the atmosphere would trickle down to the surface. But when we looked at this particular Neptune-sized planet, we saw that there were indicators that there was Rayleigh scattering in the atmosphere, which tells us that that planet's atmosphere is mostly made of hydrogen and helium.
And I guess for people who aren't aware, right, Rayleigh scattering, that is why the sky is blue.
Yeah, exactly. And the particular signature is that the planet's atmosphere was scattering light more effectively at really short wavelengths, like blue or violet, or even going into the ultraviolets. And they were able to make these measurements using a series of 1 to 2 meter telescopes around the world through a network called the Las Cumbres Observatory Global Telescope Network, which allows them to look at it from around the world, both from the northern and southern hemisphere, and they were able to prove that this is possible without something as large as the James Webb Space Telescope.
So why is observing the atmosphere of a planet so important?
So if you think of the planets in our solar system, we have 3 planets that are in or very close to our solar system's habitable zone. That would be Venus, Earth, and Mars. And the defining characteristic between all 3 of those is the composition of the atmosphere, because there's this very subtle effect called global warming that can happen for something like we see on Venus that has a very thick atmosphere. The composition of the atmosphere, the CO2, traps heat on the surface. And even though Venus is pretty close to the habitable zone, its surface temperature is very not hospitable. It's way too hot because of its extreme global warming. Whereas Mars, which is in the habitable zone, does not have an atmosphere that's really substantial at all. If it did have a thicker atmosphere, it could retain more heat and be more hospitable. So for exoplanets, yeah, the habitable zone is important, but you need to know what the atmosphere is made of to know how the temperature at the top of the atmosphere will translate to conditions on the surface.
Now, we've talked about the sort of one of the holy grails in exoplanet observing is to try and be able to see gases in the atmosphere that couldn't be produced naturally, that would need some kind of artificial process, like life, or steam engines, or fusion factories to generate in the atmosphere. So do you think this technique would be able to take us to the point that we could actually get some of the, know if there's large amounts of ozone in the atmosphere or pollutants or things like that?
So I think if we want to know the very specific types of molecules that are in a planet's atmosphere, I still don't think that ground-based telescopes are quite good enough for it, simply because we have to deal with the contamination from looking through our own atmosphere outwards. And I still think that space telescopes are the way to go if you want to observe something so precisely. But this was still a good proof of concept, and the effect that they were looking at was actually quite large. It had a very large impact on the spectrum, which is why we can still see it from the ground.
Yeah, so I wonder then, if you took a much larger telescope, if you took, you hooked this methodology up to like one of the big Keck's or the large binocular telescope, something like that, the very large array, things like that. Do you think you would get, how far can we take this? How small the planets, how far away, and how sensitive?
Ooh, so we probably still can't go too far away because the limiting factor is we still need a bright enough star. And from the ground, there's also the issue of when we're looking through the Earth's atmosphere, there are certain wavelengths or certain wavelength bands that are easier to look through simply because the Earth's atmosphere is pretty transparent in certain visible wavelengths and infrared wavelengths, but maybe not so much in the UV or the X-ray. So it's still very difficult, and we can only do it with certain targets that are close enough and bright enough and contribute enough light in just the right types of wavelengths.
Yeah, but I mean, it's still super exciting that you
It
can.
is,
This is even
really.
possible at all, right? So
Yeah,
that's fantastic.
so instead of looking, 2, 3 years into the future for the James Webb Space Telescope to make these discoveries, we're showing that we can still do some of it from the ground. And so we should go for it.
Yeah, yeah, that's awesome. Uh, okay, well let's move on. Morgan, let's talk about ULA's not bidding on some upcoming launches.
Yeah, so we haven't talked about SpaceX and This Week in Musk in quite some time, and so we're going to sneak it in kind of through the back door here. And that's because SpaceX hasn't said anything this week, but the United Launch Alliance did. And that's that they're not going to be bidding on a contract to launch the next GPS Global Positioning System satellite. So the United Launch Alliance is a joint effort of Boeing and Lockheed Martin to build launch vehicles such as the Atlas V rocket, and then use them to carry payloads into space. And for more than the last decade, the ULA has had an almost exclusive grip on launches for the U.S. Government, excluding launches used by NASA. And they launch much of what NASA launches as well, but if you're talking about something that's being launched by the Air Force, or for other national security reasons, they pretty much exclusively have been going up on Atlas V's. And that's because there's an entire sort of process that you need to go through to certify your system is capable of carrying these sorts of important payloads. And for a long time, the ULA was the only organization that had gone through that program. But we've been talking last year and into this year how SpaceX had been pushing the Air Force to complete that certification program for them, and that went through earlier this year, and now they're able to make these sorts of national security launches as well. And there's two effects kind of going on here that are keeping the ULA from bidding on this launch. One of those is that the Falcon 9 is a much cheaper vehicle than the Atlas V. And so so the ULA probably thinks that they aren't likely to win on a cost-competed basis, and therefore even spending the money to write the proposal, which is quite involved, is not a good investment. The other problem is that the Atlas V uses at its core a rocket engine that was built in Russia. And as tensions between the United States and Russia have increased over the last year or two, it's become more and more problematic for U.S. launch vehicles, specifically those that are launching national security-related payloads, to rely on Russian technology. And so the Atlas V is going to have to start using American-sourced rocket engines. And until that happens, every time they want to launch a national security payload, they have to obtain a waiver from Congress saying that it's okay to do that in this case. And there's only a limited number of those basically available to them, and GPS satellites maybe aren't the most expensive launch that they might be able to carry out, and therefore they've chosen to pass this by. But it's a big deal for SpaceX because this is a whole new market that's there and is going to continue to be there for years and years to come, not just in terms of the GPS constellation, although satellites are continuously launched to replace aging satellites in that system, but also in a range of other government-sponsored activities, from launching space weather satellites to launching communication satellites to launching spy satellites, all of these sorts of things. And it's that last one that nobody talks about, but is going to be, a continuous source of income for companies like SpaceX that is entirely separate from their business with NASA or other commercial entities.
Yeah, I mean, there are. If you watch the launches, you see the launch calendars that are happening. There are, such and such rocket launch with a classified military payload, and that happens every couple of months. a few a year for sure, and a lot of these you have no idea, and a lot of people in the sort of military journalist realm will speculate on what kind, if it's a keyhole satellite or whatever. I mean, there are literally, not Hubble Space Telescope necessarily, but there are Hubble Space Telescopes pointed at the ground, right? That we don't even talk about, that we don't even know their specific, their specifications, their capabilities, resolution, whatever. And the kinds of images that you see from, on Google Maps and stuff are a pale shadow of the capabilities that the various militaries have to be able to view. And so these need replacing. It is a new optics, new miniaturization. There's lots and lots more. SpaceX could be a viable business with these kinds of launches alone and be doing just great for themselves.
Yeah, it was only a few years ago that it became public that the National Reconnaissance Office, which is sort of a secret government organization that builds and operates the nation's spy satellites, had offered NASA a pair of telescope mirrors the same size of Hubble that they had just had laying around basically in a closet.
Just kicking around, yeah.
For many years. And that was sort of our first public tip to realizing that the telescopes pointed at Earth are likely as powerful or far more powerful than those we have pointed anywhere else in the universe.
Yeah, that blew me away when I learned that news, that the NRO had just 2 Hubble scale telescopes they had no use for because they weren't powerful enough, or who knows why they didn't need them. So we've been, of course, waiting for the big This Week in Musk revelation when it does happen, which is that SpaceX will land one of its rockets on a floating platform. When do you think that's going to happen?
That could happen as soon as just a couple of weeks from now, because SpaceX is hoping to resume its launch schedule in early December. And as part of repairing or upgrading the Falcon 9 to correct for the accident that occurred 6 months ago, they were able to make some efficiency improvements that mean that they were able to have a lot more fuel left over from a much larger range of launch profiles than they were in the past. Previously, they were really only able to attempt these landings on missions that were going to the space station, because that's actually one of the closest objects that we launch things to in space, and so you don't need as much fuel to get there, leaving more to power the rocket for a descent. Now they're going to be able to do that even when they're launching into much higher orbits, and so we should see an increased frequency of attempts to land, and given how close they were getting to landing prior to this accident 6 months ago, I think it's safe to assume that it's sooner rather than later that we'll see them pull off a successful landing.
Awesome. All right, Kimberly, let's talk about more planets that recently discovered habitable exoplanet might not be so habitable. Maybe someone should study its atmosphere.
Yeah, for sure. In this case, though, the issue is not the composition of the atmosphere, but rather a star that is much more active than we thought it was. So if our viewers recall, a few weeks ago we were talking about the NASA press release about the atmosphere of Mars being slowly stripped by the solar wind. It's a similar thing that's happening to this exoplanet Kepler 438b, but on a much, much larger scale. So Kepler 438b has been previously called the most Earth-like exoplanet ever, and I think we probably have a dozen or so exoplanets we've called the most Earth-like exoplanet ever. But this one is up there. It orbits a star that is much smaller than our sun, much cooler, so its habitable zone is much closer in. And since Kepler 438b is in the habitable zone, it's very close to its star. And what we have recently found is that this star is incredibly active, which means that it is giving off incredible amounts of harmful radiation in the direction of its planet. And just like with Mars, if this planet doesn't have a magnetic field, likely any atmosphere that it has is being blown away, not just slowly in wisps like with Mars, but could be quite catastrophic events, especially if, in addition to this harmful radiation, the star is also flinging off particles in coronal mass ejections. And so really this planet needs an incredibly large magnetic field to protect its potential atmosphere and its surface from the harmful effects of its star.
And so, I mean, yeah, a lot of people were calling this Earth 2.0,
Right.
and I refuse to call it Earth 2.0 because I guess because of the size of the planet. It's like it's a super Earth, right?
It's a super Earth. It's it's a like 20% larger or so than the Earth. It's probably a bit more massive. So they give it an Earth-like index of about 70% or so. But I refuse to call anything an Earth-like planet or an Earth 2.0 until I know its atmosphere and its surface composition. I
So
refuse.
its surface composition. Wow.
Well,
Okay.
at least I want to know its bulk composition. I want to know that it is rocky and not just, maybe 50% rocky, or maybe it's an ocean planet,
Right.
because ocean planets are even harder to make habitable over the long term. But I want to know that it is definitely rocky, that it has an atmosphere. If ever we could figure out magnetic fields, I'd love to know that too before I ever claimed an Earth twin planet. I'm much more conservative.
Yeah. I thought I was being pretty
Yeah.
conservative. You just added a whole
Nope.
pile of criteria that are really going to take a little while to figure out. One of the places that a lot of worlds are being found is around these red dwarf stars. But the
Right.
idea with the red dwarf stars is that they, in the earlier times of their history, they blast out a lot of radiation. They're really
Hmm.
very solar flary.
They
So
are.
yeah, so I mean, does this sort of give us more of an idea about what kind of what worlds might be habitable, not habitable? Are we going to see this a lot?
So we do see this a lot with M dwarf stars that are very young, and as recently as the early 2000s, it was thought that M dwarfs would be very unlikely to host habitable planets just for that reason, because when you're flinging out incredibly dangerous particles and incredibly horrible radiation at your planet, it's probably not going to be livable for very long, and it's not going to have an atmosphere for very long. So I would say if a planet could survive around an M dwarf star through the first maybe million, billion years of its life, then I would say it has a good chance of surviving for the long haul. So I don't think we should stop looking around M dwarfs, but we should definitely take them with a grain of salt.
But I mean, this process, right? This process that's perhaps at Kepler, was it 436b?
438.
438b, where its hydrogen, its water really is being stripped away from the
Mm.
planet because of the solar winds. Is that process going to happen on a lot of other worlds? Is this going to be? Are we going to find a lot of this as we look around? I mean, we're seeing it
We,
with Mars, right?
yeah, we might. I mean, not every M dwarf goes through a very active phase. There are some certainly that form very quietly and stay quiet and quiescent for the majority of their life. But a lot of them still, they do go through a very young active phase. And maybe through some magical combination of planet migration from the outer parts coming in, the planet and its atmosphere and its water might survive through that active phase. And still, M dwarfs are some of the easiest places to look for Earth-sized, Earth-massed planets. So I don't think we should stop, because I'm sure that a good fraction of planets and their water could survive.
And part of the issue is just that because they're so small compared to their star, they're a lot easier to observe than
Right.
ones that are going around much brighter stars. So we're going to probably see a lot more of these
Hmm.
planets around M dwarfs before we see the you know the ones that are around the sun-like stars.
Right, and there are certainly many, many times more M dwarf stars in our galaxy than there are sun-like stars. So it's a combination effect. There are a lot more M dwarfs, and it's easier to find these planets around M dwarfs.
Right. Okay. I think apparently our guest is sort of getting lined up here, so this may happen shortly. So why don't we talk about the most distant dwarf planet discovered? Did you get that?
Sure. So this is a leftover story from last week that we didn't get a chance to cover, coming out of the Division for Planetary Sciences conference. And what we found is a new object that kind of joins this group of objects that bridge the gap between what we would classically think of as the Kuiper Belt and populations farther out in the solar system. This object has the thrilling name of V774104, and
Ooh.
hopefully it'll get a better name than that. But what it is the farthest object that we've discovered at the time we've discovered it. And right now it's 103 astronomical units from the Sun. And that means it's 103 times farther from the Sun than the Earth is, or about 3 times farther away than Pluto currently is. And this is really, really far out there. What we don't yet know about this object is what its orbit looks like. Because we've found objects, Sedna for example, that although we discovered them much more close to the Sun than 103 astronomical units, their orbit is very elliptical and ultimately takes them much farther away from the Sun. And it's not clear yet exactly what the characteristics of this population are. Because if we think of the solar system in sort of what I'd call the modern classical view of the solar system, we have the inner solar system with our 4 rocky planets, we have the outer solar system with the 4 ice and gas giants, then we have the Kuiper Belt, which starts basically at the orbit of Pluto and extends out from about 30 times the Earth-Sun distance out to about 50. And then there is this big sort of gap in space until we get out to what's called the Oort cloud. And the Oort cloud might exist as far away as 1,000 or more times the Earth-Sun distance, and could extend indeed all the way out to half the distance of the next star. What we're finding now, though, is objects like this one, and like Sedna, that seem to be in-betweeners, that are in the sort of 75 to 100 to 150 astronomical unit distance. And this is not an area of the solar system where we predicted to find a lot of objects. And the fact that they're starting to pile up is going to have to make us rethink, in some sense, how we imagine the outer solar system is arranged.
It's interesting that they already know enough to know that it's a dwarf planet.
Well, so I think probably just about anything that we find out there is automatically called a dwarf planet. Because if you think of what we need to have a planet, it needs to be round, which means it needs to be a certain size. And this object appears to be about half the size of Pluto, which is plenty large enough to be round. And it needs to have cleared out its orbit around it. And this is what sunk Pluto from being a planet and demoted it down to dwarf planethood. And that's also something that probably is true simply because space that far out is very, very empty. And, you know, honestly, it could be that this meets the formal definition of being a planet, but we're not just willy-nilly slapping the name planet on things we discover anymore. The sort of the entry-level designation is dwarf planet, and then we start studying it more from there.
Yeah. So Miguel has just joined us, our special guest this week. So we're going to flip the order of the way this the Weekly Space Hangout works. Miguel, can you hear me? Okay. You're muted. Oh, there we go. Oh, no, your microphone is, we're not hearing your microphone. Yeah, so we're not getting any audio from you. So check to see which, check your settings and see if the microphone on your chair, no problem. Why don't we go on to your other story, Morgan, and we'll see. And then, Miguel, you can just jump in at any point and go, can you hear me now? And then we'll assume that we can't until we can. Okay, Morgan, let's talk about dudes on Mars.
Yeah, so the Curiosity rover is rolling up to a new kind of feature on Mars that hasn't been studied by any rover before, and that's a sand dune. And so certainly Mars is covered in lots of sand, and certainly it piles up into hills and valleys and things that the rovers have driven over, but to see sort of an actual sand dune feature as we see them on Earth is a new thing. And to be a sand dune, basically, you have to be steep enough to be considered formally a sand dune. You can't just be a pile of sand. There's a certain angle that you have to be a dune. And dunes are really fascinating and really important structures to understanding the surface of a planet. Because although they kind of seem like boring piles of sand, there's actually an incredible amount of physics that goes into creating what a sand dune looks like. It has to do with the size of the individual particles. It has to do with the composition of those particles, the speed of the wind, the pressure of the atmosphere, the gravity holding those particles down. And so by studying not only the shape and formation of this dune, but also how it changes, Curiosity is going to be able to help us understand these properties in bulk much more accurately. And we've, using the Mars Reconnaissance Orbiter, been able to observe this dune changing over the course of Martian years. And so this means that as Curiosity is here studying it, we're going to actually be able to see this feature evolve. And that's really a first for this sort of thing, and it's really going to unlock a better understanding of the local conditions that Curiosity is facing nearby it.
Miguel, can you hear us? You can hear us, but we can't hear you. I don't know. It's the little gear at the top of the screen. You click that, and then you pick your if you're using like a MacBook, it should be able to have your onboard microphone, and then you got to check the gain and stuff. So it's it's all kinds of technology. Also, technology is stupid, and I hate it all. So let's get on to a few questions that we've gotten from some of the viewers while we continue to puzzle through the technology. Elad Avron asks, here's a long shot. Would it be possible to observe and notice Saturn's rings using 70 by 25 binoculars? What do you think,
Morgan? It's pretty well known that I am not very astute when it comes to observing, but I did see this question and I typed it into Google, and it appears that the answer is no. The rings of Saturn are not large enough, basically, that they're going to appear visible, sort of separate from the planet to your naked eye at the magnification that you can get from binoculars like that. But
25 power binoculars.
Not quite. You kind of need to be up, it seems like, more around 35 or 40 in order to see the rings. And that's really within the range of a very small telescope.
Yeah.
And so, if you have a telescope at home, really of any size, you ought to be able to see the rings of Saturn.
I don't know if you can see my little telescope there, right up in the corner there. I'll just point up at it now. So that one there, that's So it's a 3-inch telescope. It's the one made by Celestron, and you can see the rings of Saturn in that. I haven't tried with my binoculars, but you can definitely see Jupiter's moons with that. And
you can see Titan, Saturn's largest moon, as well as Saturn with binoculars.
Yeah.
The rings are particularly difficult sometimes to observe because of the way Saturn is inclined relative to its orbit with the Sun. Sometimes we see the rings perfectly edge-on, and they disappear even from the perspective of a telescope like Hubble. And sometimes we see them relatively face-on, in which case they brighten the overall visibility of Saturn up quite substantially.
Yeah, and it couldn't be a better time to view them right now, right? There is face-on as they're going to get. So,
right.
But yeah, so the 70. I'm going to say maybe. There's something pretty magic about using binoculars, but using both eyes to see things that your brain can kind of compensate and kind of fill in some of the details. So
I would have a tripod.
Yeah,
would definitely help you as well.
With a tripod, and let your eyes really light adjust. And I would be surprised if you wouldn't at least see sort of the squished shape. Or you can use a Galileo scope, or get that small Celestron telescope. They're less than $50. I mean, they're relatively inexpensive to get a telescope that's going to let you see Saturn's rings. Come on, you should all have a good, a reasonable entry-level telescope if you're watching this show.
I do. I just don't know how to use it. I'm used to the big guys.
You're used to Hubble.
Astronomers are the worst observers.
Someone else usually sets up my telescopes for my observations, and I was never trained to set up a tiny telescope that I could carry over my shoulder.
Yeah.
Gotta learn one day.
They're not that hard. So this one comes from Hugo Burnham. Will New Horizons eventually outperform the Voyagers and traverse the solar bow shock?
So I don't know what the answer, I guess what the question is asking exactly here. New Horizons is slower than Voyager, so it won't outperform it from a speed standpoint. And its onboard power source, a radioisotopic thermoelectric generator, or basically a big nuclear battery, is expected to last into the late 2030s. So sort of on the same length of time, if maybe a little bit shorter than the Voyagers. But the instruments on board New Horizons are far more sensitive than those on board Voyager. And so it may well be able to pick up the intricacies of the boundary between the area of the sun's magnetic influence and other stars much more easily than could Voyager.
Yeah. Let's see. This is a good one for you, Kimberly. From Truck Captain Stumpy, one of the patrons on for Universe Today. Thank you so much. Not that they get any special treatment in the weekly Space Hangout, but will we have anytime soon the ability to watch or see how a CME, a coronal mass ejection, interacts with an exoplanet? This should give a limited account of a magnetic field of a planet, right?
You're right. It would give. That is very clever, actually. If we could observe such a thing, you're exactly right. It would give us an understanding of how a planet's magnetic field and give us a measurement of it, see how the star and the planet are interacting with each other. In order to do that, we would need to be able to spatially resolve this star, very sort of like magnify it a lot, so we could see the coronal mass ejection actually happening, and observe it in such a way where we can actually tell where the coronal mass ejection starts and where the star ends, and see its influence all the way out to where the exoplanet is. So our best case scenario for something like this would be probably something like a hot Jupiter planet around a very nearby star. And I don't think we're quite there yet. Plus there's the issue of a telescope that is large enough and sensitive enough to see the coronal mass ejection wouldn't be able to stare at the star itself, because it would saturate the telescope and possibly damage the instruments. And so on top of a very powerful, that has a very high resolution, we would also need a special coronagraph to block out the starlight. So it's a...
You'd have to be extremely lucky, too.
Yeah, and you'd have to know what's going to happen.
Well, and I'm also thinking, though, if the flare was pointed, like for us to observe these flares that we see on other stars, which are, you know, they can happen separately from the coronal mass ejections, but sometimes they're linked. We need the flare to be pointing at us, and so if the flare is pointing at us, then it's not pointing necessarily at the planet, and so we wouldn't necessarily see, because the only indication that we get is we see the flare off the star because it's directed in our direction, right?
Yeah.
Let's see if Miguel's audio is working now. Is it working? Nope, we can't hear you. Sorry, we can't. We still can't hear your audio. This is the point he throws his laptop across the room. But why don't we sort of do some troubleshooting after the show, and then we'll set up another time and have you back and do the interview, because I got a million questions that I want to talk to you about. Oh, was that working? No. Okay. Right. And so I guess so we would have to be able to see. But could we have some situation where maybe? Oh, that worked.
I heard something.
Nope, we still can't hear you. Could you get like I know that when you've got a star, and I know this is probably, you know, we're now moving into magnetohydrodynamics, and so it's not necessarily your focus, but could you get a situation where, you know, the charged particles are being blown off of the star, they're then interacting with the planet, and then we could see some kind of emission of particles that would tell us, oh, they're the reflected. You know,
like an aurora almost?
Yeah.
On an exoplanet?
Yeah.
Oh, that would be really spectacular if we could see something like that.
Yeah, because we can see X-rays coming from Jupiter, right? And that's Jupiter's interaction with the solar wind from the sun. Mm-hmm. So, anyway, just an idea.
Oh gosh, that would be incredible. I think we're still working out a lot of the kinks on direct detection of exoplanets, observing the light from the planets themselves.
Yeah, I've already moved way past that Kimberly now. So
Oh yeah.
I've got another idea actually for the ground-based observation is the idea of building the coronagraph for perhaps for James Webb, something that'll go like say 10,000 kilometers away. Couldn't you build a coronagraph and put it into like a geostationary orbit that's like 45,000, or is that right? 65,000 kilometers away. Anyway, and then use that ground-based telescope. But you could only observe whatever is directly, in the geostationary location. But then it would just sit there. So anyway, just an idea.
And we could actually build something like that. That's not a bad idea. I would just we could probably manage to snag maybe like a dozen, 2 dozen targets that way.
Yeah.
Sort of like a few $1 million project.
Yeah.
That's not impossible.
All right. Run that up the flagpole. See if anyone wants to get on board the geostationary coronagraph.
Maybe the Breakthrough Initiative might want to do something like that.
All right. We'll pass the idea along to them. Let's see. So Jim Meeker says that Kimberly is to aliens as Tom Nathie is to supernovae. Now, I don't know if you get the reference, but when we did the Virtual Star Party a couple of years back, Tom Nathie we were observing, I think it was M89, M90? Anyway, one of the galaxies that's well known for having a large number of supernovae, and Tom actually said in the middle of the show, oh yeah, this is M89, and there are often supernova in this galaxy. Turns out
could have been the first.
There was one. And so we actually live observed the new supernova, one of the brightest supernova that's happened in probably the last decade, live on Google Hangouts.
Wow.
Even noted that there could often be supernova in that galaxy, and then like a day later somebody else announced that the supernova had been discovered. And so we one of us actually just checked and said, I wonder if that really bright star that's in the middle of that galaxy, that Tom said often has supernova, is a supernova.
Wow.
We would have gotten credit with the discovery. So and from that point on, Dave Dickinson now double-checked every galaxy that we would ever look at from that point forward. Completely paranoid that he was missing a supernova. So so that's the reference if you need.
Thanks for that.
Yeah.
Does that mean that I get credited for any future discovery of aliens?
Yeah. So when the aliens are discovered, you're the one who gets the Nobel Prize.
Do you really want that fame, though? Because when those aliens then come and destroy us, they're going to be known as the Cartiers. And, that doesn't sound like the sort of thing you want put down in a history book.
I don't know.
Oh, that's the worst.
Crisis of the Cartiers. The movie writes itself.
Oh gosh.
Christoph Weberski asks, are we under the influence of Jupiter's magnetic field? Morgan, are we under its magnetic field's influence?
Not meaningfully. I mean, from some sort of, philosophic perspective, we're under the influence of every magnetic field in the universe, but from a practical perspective, no.
So when you say under philosophical, you mean like the fact that magnetic fields, like gravitational fields, extend to forever.
They only go to zero effect at truly infinity distance away from you. And since we are not infinity distance away from anything, in some ridiculous world, we are being affected by all of those things. But the Earth's magnetic field and the Sun's magnetic field are the only magnetic fields that are meaningfully affecting us here on Earth.
We are feeling the effect of the magnetic field of some tiny star in Andromeda. Just very, very, very little.
Yeah, unfathomably little.
Right. So yes, but not in any meaningful way.
Yes, but no.
Yes, but no. Let's see. If we got anything else if you got any more questions, Guido. Oh, sorry. Guido just gives an update. He says that in my simple 76 by 700 Newtonian, you can see Saturn's rings clearly, even with a 20 millimeter eyepiece. That's about 35 magnification. So I think that's following the same thing that you're talking about. You know, with 25 power binoculars, not quite, and that's what I've got there. With 35 power, then you're starting to see them.
And you should go look, because it's amazing. And having, spent much of my career staring at pictures of Saturn, I can tell you that seeing it as a tiny little spot on the sky is a totally different experience, and one that's far better.
Super meaningful. I mean, whenever I set up my telescope, and Saturn's in the sky, that's the first thing I go for, and it blows people's minds that they're actually seeing Saturn, they're actually seeing the rings from that star that's up in the sky. It's fantastic.
When I was
Kimberly, you were
working,
going to say something.
Oh, well, just to continue off what you were saying, when I worked at a planetarium, we did public astronomy nights. We often looked at Saturn, and many of the patrons who came by thought that we had accidentally taped a picture of Saturn to the end of our telescope, and that's what they were looking at, because it does look very picturesque.
Let's see, Miguel, is it working?
I'll attempt one more time.
It is working.
It is
Just
working.
in time for the end.
You're just in time for the end of the show, but we definitely have time for you to shamelessly self-promote your video. So for anyone who
the opportunity.
Yeah, no problem. So tell us, just give us a quick intro about who you are and what you're here to talk about.
My name is Miguel, and I directed with a co-director named Johnny Leon a new film called Skyline, about the people who are attempting to build an elevator to outer space. So we wanted to make a film about the idea of a space elevator, which is from science fiction, especially from the worlds imagined by Arthur C. Clarke, but lots of other authors as well. And we wanted to see who the people that were really working on it are, because when we heard about the concept, we were so excited about the idea and just wanted to learn more. And so we investigated and have made a film. And I think it's pretty great. It's just a film about working on a really beautiful dream of an idea.
That sounds awesome. How can people, I don't want to go too deep into the spoiler alert about whether or not it's possible, but where can people see, the trailer's available online. When are people going to be able to actually see the movie?
So our trailer is available online on our website, spaceelevator.net, but today, on Friday, November 20th, we are live on various platforms, including iTunes, Amazon, VHX, Vudu. I think I may be forgetting a few others. Xbox Live is one, but many video platforms. We're not on Netflix yet. We're hoping that we will be, but it's available right now as of today on iTunes and on Amazon.
And people can purchase
purchase
the
or
license.
rent it. Yeah.
Yeah. Okay. Awesome. And you just you won an award, right? At a recent.
We recently had our premiere at the New York City Film Festival, Doc NYC, and we were, I think, one of the only science documentaries there. I don't believe our film was in competition at that festival.
Oh, okay. All right.
Up right now. But anyway, we had a fantastic premiere on Sunday, and we were there as filmmakers, but some of our guests who are scientists in the film, former NASA advanced concept scientists and things like that, really stole the show, and the audience had so many questions for them and stuck around with them for hours after the screening, wanting to learn more about the space elevator and how it was going to work.
How much did you know about space elevators before you engaged in this documentary?
I knew just enough that I had gotten into a lot of discussions or maybe even arguments about the feasibility of the project. So I think, I knew some basics about how it would be positioned and what some of the challenges were to building it, but not really. I knew people were working on it, but I didn't know who they were. I knew NASA had done a little bit of research into the concept. And so, yeah, what I really learned was, in the course of making this film, a lot more about the material challenges and also a lot more about the people who have actually been working on this concept, in some cases, since the 1960s.
And now that you've completed the documentary and posted it up, what new things did you learn, and especially sort of about the feasibility? How far has this concept been taken now?
Well, what I've learned about the feasibility is both good and bad, which is, I've been to a lot of carbon nanotube research facilities in places where they're actively producing carbon nanotubes. And so it's exciting the amount of work that's being done in that area, but it's also very daunting how much work remains to be done. And so, I think we started the film a few years ago, and I think we thought that the breakthrough was right around the corner, and it hasn't come yet in terms of making carbon nanotubes that are quite strong enough to build the elevator. But I do strongly believe, based on the research that I've seen, that research is going to be successful.
Right. I mean, carbon nanotubes being I guess, the only theoretical material that's strong enough to build you a cable that's, what, 45,000 kilometers long, right?
That would be by far the most likely candidate of material, and there might be a few other variations on that material, but essentially that's an accurate summary.
How far? I know one of the issues is even making carbon nanotubes, like extruding them or weaving them. How long have people been able to sort of make things out of carbon nanotubes?
Well, that question we address in our film, and Bradley Edwards, who did a lot of the original research for NASA and is one of the primary inventors of the elevator concept, talks about how we've seen carbon nanotubes that are this long, that are 50 centimeters long, and that is a long enough length to weave with. And so even at that length, it's feasible, but we haven't seen a reliable way yet to make lots of them at that length.
Right, and so you would need to be able to make lots of them at that length and weave them together and sort of extrude this cable that would go on for a long time.
The quantities that are involved are very huge because the elevator is, at a minimum, about 40,000 kilometers long.
Right, if you use some kind of counterweight at the top. Like a great big asteroid or something. Exactly. But I mean, what were some of the things that maybe in creating this documentary, new things you discovered, things that you hadn't really thought about, or things that gave you some sort of more enthusiasm for the concept?
Some of the things that I discovered were kind of backwards looking in a certain sense, and reason that I would urge everyone to see the film is we learned a lot just by listening to some of the words of science fiction authors like Arthur C. Clarke and Isaac Asimov about things that they had predicted that did sound very outlandish when they were talking about them 50 years ago, but turn out now to have this kind of air of inevitability. And I feel that one day the space elevator might be among those concepts.
Did you get a chance to look at sort of its viability on the moon? Because, in fact, the moon makes a great place to put a space elevator.
The moon is considered, by me and by many other scientists, is considered a place where we could potentially build a space elevator starting tomorrow with existing technology. We didn't totally address it in our film because we really wanted the film just to introduce people to the concept in the first place of an elevator to outer space, and because it works on a different principle, and also I think I and many other people think the economic argument for the moon elevator is a little less impressive than for an Earth elevator. We saw that as something of a diversion, but we did work with a lot of scientists, and a lot of the subjects of our movie, including Michael Lane and Jerome Pearson, have worked on the moon elevator as well.
And so you mentioned that when you did sort of a screening of it, and a lot of the people just had a million questions for the researchers. Do you find there's like a ton of enthusiasm for this idea and just for space exploration in general?
Yes, I do, and we found on a very personal level that whenever we talked about the subject, it generated a lot of passion, and so we wanted to make a movie to take the discussion to a much wider group, and hopefully people can look at it and figure out where they stand, if this is a feasible project and something that we should be working towards and hoping for our future. I tend to believe that it is, and so we wanted to create this film to bring the idea to a wider audience.
Yeah, it sounds fantastic. So once again, if people want to learn more about it, where should they go?
Spaceelevator.net is our website.
Great.
So spaceelevator.net.
Spaceelevator.net, and if they want to now, as of today, purchase either purchase a copy or rent it, they can do so, right? iTunes.
That's right. The film is Skyline, and you're able to find it on Amazon, iTunes, VHX, and many other digital platforms. So look for it on any platform that you like for that type of thing.
Kimberly or Morgan, let's just start with Morgan. How do you feel about space elevators?
So, I am generally optimistic about them from the standpoint that we need this path to space in order to enable our long-term exploration of the solar system. And I think the larger challenge is maybe not technical, but fiscal, which is that space elevators are likely to cost an extraordinary sum of money, certainly in the tens of billions, if not more than that, and take decades or longer to construct. And right now we don't have a good model for carrying out this sort of international cooperation at this level over this long, sustained period of time. Because once you start building the elevator, you can't really stop. And you're going to need to continue to support it and continue to fund it for a long time coming. And I don't know if we're ready as an international community to do that, even if we can overcome all of the technical barriers.
Kimberly, is it possible that around KIC we're actually seeing not a megastructure but a bunch of space elevators?
Well, that would certainly be interesting. I don't think that a space elevator would do quite the thing that we're seeing around that particular star, but it could certainly be. It's okay.
It was a ridiculous question. I didn't.
That's all right. No. In all seriousness, though, they could be building something similar to a space elevator, but just on a much grander scale. I think that the space elevators we're talking about in terms of what we can build.
Space roller coaster.
Space roller coasters. You never know. But the ones I think that would be feasible for us in the nearby future wouldn't be anything quite that large, but are certainly a very exciting prospect.
Miguel, one of the great things about, space is expensive. Getting to space, $10,000 a kilogram, it's ridiculous. It's too much. I'm not going to pay. But a space elevator, I think the real dream of that is just how much it brings down the cost of getting up into space. If a space elevator does get built, what kinds of costs are we looking at for being able to get into space?
I think that is the main reason for the argument for the space elevator. I think it's hard to estimate because since it requires a material science breakthrough, we don't know how much it will cost exactly. But I do believe we'd be looking at on the order of 1,000-fold decrease in the price of getting into orbit. To Morgan's point, I believe that the rationale, and we talk about this in our film, for why we would make such a huge investment over such a long time period is that we might really look at that cost savings as a reason to use the space elevator as kind of a permanent energy solution for Earth. Because with easier access to space, you have much easier access to the ability to have solar energy farms essentially in space, which is an idea that is thrown around a lot. There have been New York Times editorials calling for solar farms in space, but the cost of getting the machinery to orbit is prohibitive at this point. But I think, Japan is very interested in a space elevator, and I think that's because that's a country that relies on nuclear power and is maybe looking at long-term ways to get away from that. So I think that would be the reason why we'd see a huge effort on the scale that we're describing.
Yeah, it's super exciting. So we pretty much have to wrap up the show now, but I'm glad we got a chance to actually talk with you and help you promote the video, because this just sounds awesome. That there's going to be, people can sort of steep themselves in the cutting edge, the most recent information about space elevators, which is going to be great. So I will definitely try and get a chance to watch it as soon as I can, and I encourage everyone else to see if they can get their hands on a copy as well and watch it. So thanks, Miguel, for coming and taking the time to talk with us today. Really appreciate it.
Thank you again. Thank you so much for having me.
Okay, well, as we wrap this up, Kimberly, where can people find out more about you and what you do?
So if you want to know more about what I do, you're of course welcome to visit my website, www.kimberlycartier.org. You can follow me on Twitter at AstroKimCartier or on Google+.
All right, Morgan, where do people find out more?
And you can follow me on Twitter at Morgan Renberg, where I try not to post too much about what I'm watching on Netflix, as well as check out my website, morganrenberg.com.
But if you do watch a space elevator documentary on Netflix, you'll let people know.
You should live tweet it.
You'll
Indeed.
live tweet
Yeah.
it.
Oh.
Ooh, that sounds good.
I'll follow immediately for that.
And Miguel, if people want to follow you specifically on Twitter, are you there?
I'm on Twitter. I have Twiguel, Twiguel. It's my name with a TW for Twitter.
Perfect.
Twiguel.
And one last way for people to find out, what's that website again?
SpaceElevator.net.
Fantastic.
And SpaceElevator.net has links to all our social accounts as well.
All right. And again, this is a sort of, we engage with the community here. The fans are the producers of this show. So if you want to be a part of that, go to the WSH Crew community on Google+. Actually, Google+ has completely revised the way the site looks now, and the communities actually are pretty sort of active in their interface now. So it should be a lot easier to actually find the WSH Crew on Google+. So join that. Join the community, make your recommendations and suggestions for guests and for some of the stories that we'll be covering here on the show. We'd love to have you be a part of the show. Well, thanks everyone for joining us this week. Thanks to Miguel for getting through all the technical hurdles to talk about his documentary, and thanks to Kimberly and Morgan for keeping the flame going as we talk about the big space news. So, thanks for watching, and we'll see you all next week.